Alright, so I'm going to try to do this video explanation on the board. I think I'm recording the webcam and the screen, so you should be able to choose whichever one you want to view, whichever one makes your viewing easier. Number 21 here, the way this was set up on the AP test, this chart applied to like numbers 21 through 23, and there was like a pre-explanation up here that told you how many people there were, and it made number 21 a heck of a lot easier with that information, and it just didn't pop up when I did this way of getting the problems on your packet. But they're asking for which of the smallest one's an outlier here in 21, and you see 1.5 times the IQR below the lower quartile. That is Q1 minus 1.5 times the IQR. And then you see 1.5 times above the upper quartile. That is Q3 plus 1.5 times the IQR. You need to know those things. You need to know how to find that. You need to know if things are outliers or not to tell me. But I'm not going to do this question. It's just way too much without like the pre-explanation. Because I'd have to go through and total up all of these, cut it in half, look at all of those, cut it in half, look at all the bottom, top half, cut it in half, and find that distance. And just with the time, the way they presented it, that's not reasonable in a short amount of time. So that would not be on your test, and I would not worry too much about it. Number 22. Oh, the answer to the last one is D. So if you're wondering if you did it, and you're like, hey, I want to make sure I did it right, 21 is D. 22. So they're giving us the section 1, section 2, section 3. So I'm just eyeballing, okay, this has the biggest range. This has the smallest IQR. Remember, 25%, 25, 25, 25. I don't know what the question is asking yet, but I'm just kind of talking through it. So I know the correct answer is E. So if I just kind of talk through that one. At least 50% of the scores in section 3 are higher than all of the scores in section 1. This is similar to that golf one from earlier. Right here is the top 50% of scores in section 3. Well, every one of those scores is better than anyone in section 1. And that's true, so that was your answer. And again, there are important reasons why some of the other ones are wrong. It would just make this video so long and boring that you guys would all just give up and not watch. 23. So the answer here is D. They give us the information a little bit different way here. So sometimes you have to do some extra stuff with this chart. This one's not too bad. They give us Q1, they give us Q3. And then part D says the interquartile range is 65, and that is true because 95 minus 30 is approximately 65. All right, so that's good for 23. 24, which of the following is the best description of the histogram? So what I've got here, and I haven't looked at the answers yet, but we get kind of a few shapes that are going on in this. So this is skewed left. That's skewed right. That's approximately normal. That is bimodal. So the mode is like a peak. And you've got two peaks. So you've got two modes. So like the first thing I notice here is we kind of got that bimodal shape going on, where there were a lot of data down here between 1 and 150 and a lot between 225 and 300, but there just wasn't much in here. And kind of the weird thing you got to be careful of there is if I take the mean of this distribution, or the median, it's probably going to be some number in here, but that number really doesn't represent the whole data set very well. So again, I haven't even gotten to the question yet, but just talking through what I see. This is number 20. This scrolling back and forth is why you guys might not like the video notes. We'll see. 24 is E, so the distribution displays two clusters, one around 125 and one around 260. Has a range of more than 250. So that's what I was saying. We got a cluster here, and then our range, if I subtract the big minus the top, the short, top minus the bottom is about 250. And that's E. It says at most because the smallest number this could possibly be is 75, but this represents any number between 75 and 100, so this might be a 90. Like the smallest data set could be 76, 78. The biggest one over here might be 325, but it might also be 301. So our range could be from 750 over to 325, but it could actually only be like from 100 to 300. So that's why it says at most. Okay, 25. Which of the following is the best description of the distribution of points earned? So this is really similar to the last one we just did, and this is a tough. Okay, I could argue this is skewed left, and they didn't put that as an option, which I'm really glad about, because you could kind of draw this and go. I don't think it fits perfectly, but I'm glad they didn't put it as a choice. It's not approximately normal. Approximately normal is the bell. We don't have that. Bimodal without a gap, that'd be a little strange. It'd be like I'm not even sure what that would look like. Bimodal with a gap. We got a cluster, we got a cluster, we got a gap. C is your answer. It is not skewed to the right. Skew to the right without a gap, look like that. Skew to the right with the gap is not something that ever really comes up. They're just kind of throwing in terms and see if you pick them. So that was 26. All right, so 26 is C. You got this histogram. There are, how many data points? 304 data points. All right, so the first thing I see, this is skewed to the right. So this would look like this would be kind of your normal distribution, but we got this extra data over here. Skews to the right, and what that does is pull the mean up, which makes the mean greater than the median. So 304, so if I look through my answers, just kind of talking through some of the wrong ones. The minimum price is $250,000. I don't know that. I know the minimum price is between $250,000 and $500,000. It might be $499,000. Same with the maximum. I don't know that's the biggest. I know the biggest is somewhere in between 2.25 mil and 2.5 mil, but I don't know which of those it actually is. C, the median price is not greater than $750,000. So let's take a look at that one. So I know I've got 304 homes. So to find the median, you can always add 1 and then cut what you get in half. So 305 divided by 2 would be 152.5. So your 152.5th data point is the median. But that doesn't exist. So we find the 152nd and the 153rd, and we average them together. So I know I've got 38 of them there. And by the time I get done with this section, 38 plus 120, I've got 158. So my 152nd and 153rd must be in here. I don't know where. I know they're between 500 and 750, so the median is somewhere in this range, but I don't know exactly where. So that's why it says the median price is at most 750, because we know we have to be in this range, but it could be slightly higher, it could be a little bit lower. Like it's possible every single data point in this bar is at 501. So that would be median, but we don't know that. All right, number 27. All right. Two rabbits, mean weight's 45 or 5 pounds, the standard deviation is 3, which is most likely true. This might be one you're not ready for yet. Let's see. That's a tough one. I think we can understand it. So the answer is C. Distribution of weights is skewed to the right. If you just think about why, if I started to kind of try to sketch this out, I probably wouldn't put this on your test this unit, but it could be on your test next unit, so don't freak out if you don't get it right now. But it's good to start talking about it because it's coming up. So the mean weight is 5 pounds. If I throw that on here, the mean weight is 5. Now the standard deviation is 3 pounds. Well, if I go over to 2 and over to 8, that kind of starts my normal curve. So you want to move over, I moved over 3 because that's the standard deviation. Again, you're not fully expected to understand this yet, but you will be like next week, so it's not going to hurt you to hear. If I go over another standard deviation from here, I'm at -1. If I go over another standard deviation from here, I'm at 11. Well, 11 makes total sense. I can do that. I go to my next one, it's 14, and now I'm going to get, there is data over here. The problem on the other end is I'll run into this and I start to kind of do that, and I can't because I run into 0. So I cannot have any data in this lower part. It just cuts it off. Well, what that does is take what could have or should have been a normal curve and just kind of chop it so you get this, and that's skewed right because you have this tail on the right-hand side that is pulling everything in that direction, and you don't have the tail on the left-hand side that usually is there to balance it out. So there's some skew in this one, which is definitely part of this chapter, but the standard deviation part is not quite. But it's going to be skewed to the right because we can't go to the left because 0 cuts us off. All right, 28. 28 is A. The distribution of 4 variables is shown in the following histograms. Which one is not represented by the 4 distributions? So I'm going to kind of need to see my choices here. So we got uniform, bimodal, skewed right, skewed left, symmetric, and uniform. Okay. So let's sketch these down here. Uniform is this. So you've got, it's basically like a box. You'll have like bimodal is you got a cluster and then a cluster. Skewed to the left is you have a big tail on the left-hand side. Skewed to the right is you have a big tail on the right-hand side. Symmetric and unimodal, so unit means 1. Symmetric in 1 mode is like your standard bell shape. So if I scroll back up and look at these shapes, we've got bimodal. We've got skewed to the right because that tail pulls things over. We've got skewed to the left because that tail. And we've got symmetric and unimodal, which is your approximately normal. We do not have uniform. So A is your answer there. 29. Histogram shows the number of minutes playing a computer game, which of the following statements is correct. So the first thing I notice here is that skewed to the left. So again, approximately normal would look like this. You have this nice smooth bell. But what we just did, by placing these points over here, it takes this red line and extends it, and now it gets pulled. These pull things to the left, and that's a skewed left. So skewed left, is going to pull the mean that way. So the mean is less than the median. And again, I haven't even gotten to the question yet, but that's what I see, and that's my guess what they're going to ask. What number are we on here? This is number 29. Distribution is skewed to the left. And so we kind of already said that, just with my talking through with the notes, and we're good. All right, let's jump to 30. Mean of standard deviation. So as I read this, you might not be responsible for this yet either, but let us see. Mean standard deviation, which the following best describes standard deviation. So yeah, we haven't learned that yet. So the answer is A, but that would not be on your test for this unit. 32 or 31, sorry. Number of hurricanes, we've got a min, a max, a Q1, so lower quartile is Q1, median is essentially Q2, upper quartile is Q3. Which of the following statements is true? Right? Smallest observation is 12, and it's an outlier. Well, I don't know yet if it's an outlier. I think I'm going to have to find out, though. So, see an outlier, 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 outliers, outlier. So I better find out if there's outliers or not. It's all right. It's good to go through that. So, outliers are lower than Q1 minus 1.5 times the IQR. So Q1 is 15 minus 1.5. Well, the IQR is the difference between those two, so that's 3. This would be 10.5. Our lowest value is 12, so we do not have any outliers in the lower direction. Q3 plus 1.5 times the IQR give us 18 plus 1.5 times 3, so that's 22.5. Well, my max is 24. So be careful here. You have at least one outlier. You don't know how many you have. It could be that there's 23 right next to it. It could be there's a couple of 23s right next to it. You don't know, so that's why this wording here becomes important. So if you look at E, 24 is an outlier. That's true, and it's possible that there are other outliers on the height of the data set. So that's what I was saying. We don't know if there's a 23, a 24, and then there are no outliers at the low end. So we're good there. All right, 32. We're going to collect the data on the following variables. Which of the following is considered discrete? Discrete is where there's gaps in between the possible outcomes. So how many years have you attended? No. What hour are you in pre-calc? First hour, second hour, third hour, fourth hour. But you can't be in like 1.72 hour or 3.19 hour. So discrete means there are gaps. So the height of a person is not discrete. Because you could be 5.387 inches tall. You could be 5.38712 inches tall. Like all of these things are possible. All those decimals work, so that's what's called a continuous variable. There's no gaps. The weight of a person, again, you can get into decimals here, so that's continuous. The length of a person's arm span, it could be 2.7 inches, 2.78 inches, like that's continuous because you can get into decimals. Time it takes to solve a puzzle, again, 2.37 seconds. Well, that'd be pretty fast, I guess, but 60.15 seconds or something. And then the number of books, that's kind of debatable. I mean, I could see someone saying, well, I read 3.5. But the best answer here, I think, is number of books. Finished reading. How many did you finish reading? It's 1 or 2 or 3. I didn't finish 1.7 books. I could kind of argue that, but I think given our choices here, this is the one that doesn't have gaps. 33, greatest standard deviation. So I probably wouldn't put this on this unit test either. So the MyAP classroom kind of screwed me a little bit with some of these standard deviation questions I didn't expect, but that's what's coming next. Standard deviation is the average distance from the mean. So in every one of these situations, the mean is 5. So if you just start thinking through, I'm not going to do them all, but how far is this point away from the mean? How far is this point away? How far is this point away? How far is this point away? So this might be 4, 3, 2, 1. This is not anywhere away. 1, 2, 3, 4. If I average those, basically if you're averaging, you get a standard deviation. Well here, these are further away, right? This is like 4, maybe 3.5, 3, 2.5, 2. Like all of these are really far away from the middle. Here we've got some really far away from the middle, but we got a couple really close to the middle, which is going to lower our average distance from the middle. Again, I've got a couple here, so the distance from the middle for those is 0. Distance from the middle for those is very small. This has the most points that are farthest away from the mean. So that's going to be your standard deviation. So that one is B. And again, I don't think I would put that one on this test, but I could very easily put it on the next one. 34. Okay. Data on homes, mean, median, Q1, mean, minimum, Q1, median, Q3, maximum standard deviation. To determine an error was made and that all of the areas should have been 100 square feet greater than what was reported. The areas were corrected and the new summary statistics were reported. What are the IQR and the standard deviation of the corrected areas? Okay, this is a little tougher one. Again, probably wouldn't be on this test, could be on the next one. I know I keep saying that, but I know not everyone's watching every question. So if you watch this straight through, I probably said that about like you're not responsible for it 6 or 7 times. But if you just watch them one at a time, maybe you're only seeing it once. So that's why I keep saying it. So basically what happened is, let's look at this with like a small data point, a data set. 3, 4, 5, 6, 7, 8, 9. That's our data set. Well, there's my median. This would be my Q1. This would be my Q3. And my interquartile range would be 4. Let's say that I added 100 to all of those. I screwed up. These actually aren't 3, 4, 5, 6, 7, 8, 9. This is actually supposed to be 103, 104, 105, 106, 107, 108, 109. Well, now, this is your median. This is your Q1. And this is your Q3. And your IQR is still 4. So that didn't change. So what happens, it's like you got this dot plot over here. And then every data point needs 100 more. So the whole dot plot just moves over 100 spots, but the shape of it doesn't change. The spread outness of the points doesn't change. So Q1 is just going to be 100 points higher now, and Q3 is going to be 100 points higher now. But the IQR, well, that was 102. Subtracting those, and that's 102. So the IQR doesn't change. And then the standard deviation doesn't change either, because the dots don't spread out as much, and that's what we'll get into a little bit more next unit. So this one's A because those are both just exactly what they were in the chart. So they don't change. I just picked up my data, kept it in the same shape, moved it over, and dropped it down, and all that stuff is still the same. The mean changed. Everything got bigger, but not these. All right, 35. When juniors or seniors are grouped together, could physics majors have a higher GPA than chemistry? So I think what they want you to look at here, what they're trying to get you to do, is, okay, well, those, 2.8 is smaller than 3, and 3.2 is smaller than 3.6, so therefore the average down here is going to be smaller than the average over there. Well, the problem is you don't know the sample size. Let's say there was one junior. We don't know the size of any of them. So let's say there's one of these people and 100 of these people. Well, your average is going to be pretty darn close to 3.2, maybe like 3.19. And let's say there's 100 of these people and one of these people. Well, your average is going to be pretty darn close to 3. This is what's called Simpson's paradox. I've never seen them ask that in the AP test, but this idea that if you just straight average those and average those, it looks one way, but if your sample sizes are different, it can look the complete opposite. So be careful when they ask you to make a general statement without sample sizes. So that one is yes, it could happen. Whether it does or does not happen depends on numbers of juniors and seniors in each major. Right. 36. Skip it. You don't know that. The answer is E. If you're interested, wait till next unit. $37. Similar to the one we just did, add 100. So here, we're going to subtract instead of add. That doesn't really do much. So we're going to subtract 3 from everything. 100 recorder measurements. Darn it, I screwed it up. I forgot to subtract the weight of the, I don't know, something they were saying that or something. But I got to subtract 3 from everything. So I had a bunch of data. And I don't know what it looked like, but let's say it was something like this. And this is, so let's say that the weight of the mouse in grams was 20, and it was just kind of like distributed around in this shape around 20. Well, I screwed up. So really, that exact shape needs to be moved over to there. Well, if I do that, if everything moves back 3 spots, every number will drop down 3. So the median will drop down 3 with it. Every number will drop down 3, so the mean will drop down with it. The first quartile will be 3 lower. Third quartile will be 3 lower. You could almost think about like if you got a box plot here. It's just going to pick up and move over 3 slots, and now you've got a new box plot there. Well, everything just is where it was, except 3 shifted over. Well, the inner quartile range, though, will not change. Because the size of the box doesn't change, you just moved it over. That one stays the same. 38. We're going to skip this. You're not ready for it. If you want the answer, it is C. Don't worry about it. My AP classroom got a little aggressive putting some of the next chapter stuff on there. 39 and 40, and then I'll make a new video after this. So based on the box plots, which of the following is the same for both leagues? Just eyeballing up here, my guess is the answer is going to be IQR because those 2 boxes are the same. Like the medians are not the same. The range is not the same. I guess you go over there, over there. So let's see what we got. So yeah, 39 is B. The inner quartile range will be the same. That's the size of your box. 40. We want the lowest standard deviation out of all 3 of these. Out of all of these graphs. I don't know yet. Lowest standard deviation means you want the most data like clustered in the middle. You do not want things to be spread out. So this is very spread out. Your middle is, probably around here, around 5, but all of the points are far from there. So if I start looking at the average distance, there's no points with like a 0 distance to bring down that average. Here, your average is probably around this 6 number, and so you've got some points with a distance of 0, some points that are a little further away, and some points that are pretty far away. I think we can find something a little more packed together tightly than that, though. This is really spread out, those gaps. This is packed a little bit tighter together. Skip. So I'm down to D or E here. And I'm just looking at, well, the middle here is probably like 8, and everything is within two units. The middle here is 5, and there's things that are like 4 units apart, 5 units apart. So this is a more normal curve, and this is a little bit skewed left. That's not what they're asking. They're saying where is there the smallest standard deviation, so packed the most tightly together. And that would be P. All right, so I'm going to stop that for now. Now I've got 1 through 20 and 21 through 40 on there. I'll keep adding. You keep checking, doing your work.